In this video, we're going to focus on simplifying expressions by using exponent properties, and we're going to mix all of the properties together. So before we mix all of the exponent properties together, let's recap what we know about exponents so far. So if you look in example A, what you should see is property number 1, where we have common bases all being multiplied that have the same base, and we simply need to condense them down. So here what I notice is I have a to the power of 5 and a to the power of 7. And because they have a common base and they're being multiplied, I know that I can add their exponents together. So here this would become a to the power of 12. And then the b values, those can also be added together to be b to the power of 7. So we add the exponents of common bases together that are being multiplied. In example B, what you should be seeing is the powers to powers rule. So notice that we have powers raised to powers. We have two items inside those parentheses, and so both of these powers of 2 and 3 are going to be multiplied by 5. So we now have b to the power of 10 and a to the power of 15. So that's our powers to powers rule. In part C, I notice that I have a fraction. So here I'm noticing, okay, I have a to the power of 6 in my numerator and a to the power of 7 in my denominator. I know that when I have a common base in my numerator and my denominator, I can simply subtract their exponents. So here 7 minus 6 leaves me with 1. And then I put the remaining a, which is a to the power of 1, wherever there were more a's to start, which is my denominator. And then if I focus on b's, so I have b to the third and b to the sixth. 6 minus 3 is 3, so I have b to the power of 3 remaining, and that's in my denominator because there were more b's in my denominator to start. 6 is bigger than 3. Then if I focus on the c's, I do 7 minus 5, which leaves me with c to the power of 2. And because there are more c's in my numerator, because 7 is bigger, c to the power of 2 goes in my numerator. Then I have d to the power of 5, and remember this is really d to the power of 1. So I take 5 minus 1, which leaves me with d to the power of 4. And because there are more d's in my denominator with the 5, I have d to the power of 4. So that's our third property. And then I mixed properties 4 and 5 together here. So first note that I have 5 to the power of 0. And remember that anything to the power of 0 can be rewritten as 1. So we're just going to write this as 1. And then I want to keep anything with positive exponents right where it is. So here I have k to the power of 4, n to the power of 5. But what I notice is that p and m both have negative exponents, and I want to rewrite those as positive. So here I'm going to take this exponent of negative 3 that's with the m and move it into my denominator, or the reciprocal, so that it becomes positive. And then I'm going to take the negative 2 exponent of p, move it up into my numerator, so I get p to the power of positive 2 by using that reciprocal. So here I have fully simplified this now by using only positive exponents. So here are our 5 properties, and on the next couple slides we're going to mix them all together and try to simplify slightly larger expressions by utilizing these properties. So now as we combine all 4 properties together, this is kind of the process I suggest you go through. While there isn't one correct first property to use, typically it's easier to make mistakes if you don't go in this order. So here you're going to start with the parentheses. Get rid of those parentheses just like you do with the order of operations and use that powers to powers property. Then from there, I always find it easiest to rewrite all of my exponents as positive exponents. So essentially getting rid of all of those negative exponents. So I start with my powers to powers, then I rewrite everything as positive. Then I essentially simplify the top and the bottom, so combine common bases across the top, and then common bases across the bottom. And then from there, use that division property where you have to subtract your exponents. So let's simplify the following together. Here I notice that I have powers to powers in part A right here. So I notice I have powers raised to other powers. I'm going to simplify that first to get rid of those parentheses. So here I have 3 to the power of 1, x to the power of 4, and y to the power of 1. So I'm going to multiply each of those by 2. So here I have 3 to the power of 2, x to the power of 8, and y to the power of 2. And then the rest of this remains the same. Then from here, we're going to rewrite all exponents to be positive. But in this case, we can see that every single exponent for every single term is positive. So we don't need to do this step here with example A. Then we're going to combine bases across the top and bottom. Now this one, luckily, we only have a numerator. We don't even have a denominator. So we can combine common bases across the top and across the bottom, but we're just going to combine them across the top. So here I'm going to start with negative 2 to the power of 3. There isn't anything else with a base of negative 2, but I'm going to evaluate this one because it's a number. So negative 2, if I use my parentheses on my calculator, to the power of 3, you can think of as even negative 2 times negative 2 times negative 2, which I know to be negative 8. Then from here, what I notice is I have another number of 3 to the power of 2. So I'm going to simplify that next. 3 to the power of 2 is 9. And then I'm going to focus on my common bases. So I notice here that I have y squared and y squared. And I know that I'm going to add exponents here because they have common bases and they're being multiplied. So this becomes y to the power of 4. And then I have x to the 4th and x to the 8th. Again, another situation where I add the exponents. So I have x to the power of 12. So here I can write my final answer by multiplying these two values together. So I get negative 72, y to the 4th, x to the 12th. And I don't have to apply this last step here because I don't have any division. So now I'm going to go through these same 4 steps again as I go through part B. So let's start with parentheses and powers to powers. We don't have any. We also don't have any negative exponents. So what I need to do next is combine bases along the top and the bottom of my fraction. So here if I focus on the top, what I notice in common is I have an x to the 12th and an x to the 7th. Those have common bases and they're being multiplied, so I'm going to add their exponents together to get x to the power of 19, and then there aren't any more y's in the top, so I leave it as y to the 3rd. I then look in my denominator and I notice I have y to the 10th and y to the 8th. Those two have common bases, so they combine to be y to the 18th. And then the x squared is still there. So I've taken care of that step. I then use that division property or that fraction property. So from here, what I notice is I have 19 x's in my numerator and 2 x's in my denominator. So I take 19 minus 2, and that leaves me with 17. So I have x to the power of 17. And because I had more x's in my numerator to start, I have x to the power of 17 in my numerator. I then focus on the y's. So I have y to the power of 3 and y to the power of 18. So 18 minus 3 leaves me with 15. So I have y to the power of 15, and because I had more y's in my denominator, that y to the power of 15 is left in my denominator. So here we have a more simplified version of our original expression.
So let's take a look at a couple more examples. So here with this first problem, I really like this first one because it has a lot of different strategies contained in it. So what we're going to start off doing first is we're going to start with the powers to powers rule. So here we can see that we have parentheses and we need to take care of the powers to powers. So I'm going to go through and I'm going to add in all of my sneaky ones there. And then I'm going to apply the powers to powers. So this 2 multiplies by the 1, the 2, and the 4 because those are all powers contained within my parentheses. Now, from here, I need to be really careful. Because this negative 2 right here is currently contained in parentheses with the exponent on the outside, I'm going to leave it that way to start. Then from here, we take our 2 times 2, which gives us an exponent of 4 on the x, and 2 times 4, which gives us an exponent of 8 on the y. And then from here, I'm going to leave this second fraction alone for just now as I start to finalize my fractions. So the next thing here, it says to rewrite all exponents so that they are positive. Well, I don't need to do that because there's no negative exponents. Well, yes, I see a negative number here. That's not a negative exponent, so I don't actually need to simplify that any further until the time comes with that step. That's not a negative exponent, so it doesn't apply right now. Now, the next piece here says combine common bases across the top. So I'm going to actually combine any common bases I see in the top. So what I see when I look here is I see an x to the 4th and an x to the 1st. So those are going to become x to the 4 plus 1, which is 5. And then from here, the y to the 6th can't combine with anything, so we have 6 that stays. And then here, I can actually evaluate this. I know this is negative 2 squared, or negative 2 times negative 2, which is a positive 4. Then if I look across the bottom, because that simplifying across the bottom comes next, these can't be combined further, so we have just y to the 8th in the bottom and x to the 7th. Then from here, it says that the third or the fourth step is that we're going to use that division property where we have common bases in the top and in the bottom. So here, I'm going to leave the 4 exactly where it is because there's nothing else but the common base of 4. What I notice here is I have an x to the 5th and an x to the 7th that are both in the top and the bottom. So what I do here is I take the bigger exponent minus the smaller exponent, which is 2, which means I have an x squared, and because the 7, which is bigger, was in the bottom, that x squared goes into the bottom. And then I look at the y's here, and I see I have an exponent of 8 and an exponent of 6, so I'm going to subtract those to get 2, which means I have a y squared, and because the y to the 8th was bigger and in the bottom, the y squared remaining goes into the bottom. So here is my final answer, fully simplified. Now, we're going to look at this second problem here, so I'm going to erase my steps here. Let's see if it'll let me. There we go. And I'm going to repeat this same process with this next problem. So the first thing this says is to deal with the parentheses, which I'm going to do. So I'm going to put in all of my sneaky ones and then multiply every exponent by negative 4. So I have 3 to the power of 1 times negative 4 is negative 4. Then I have negative 2 times negative 4, which is a positive 8. And there's 1 times negative 4, which is a negative 4. Then from here, it says rewrite so that all exponents are positive. Now I notice that I have some negative exponents, so what I need to do is I need to turn this into a fraction by placing it over 1, and then I need to move any negative exponents that I see to the opposite side of the fraction to make them positive exponents. So that's what I'm going to do here. So as I do this, my a to the 8th, because it is positive, stays in the top, but my 3 to the 4th moves to the bottom and the exponent becomes positive. And my b to the 4th moves to the bottom, and as I move it there, it also becomes positive. Then if I take a look, I notice that I have a numerical value that I can simplify. So 3 to the 4th I know is 3 times 3 times 3 times 3, and if I evaluate that, I get 81. Then from here, says combine common bases in top and bottom. Well, I don't see any of those I can combine. And the division property doesn't apply because I don't have common bases in top or bottom. So here is our final answer. And then finally, this bottom problem down here, we're going to go through this same process again. We're going to go through those steps. And the first thing says to deal with the parentheses. Well, I see none, so that's not a step I have to worry about. Then from here, it says to rewrite so all exponents are positive. So the first thing I'm going to do is I'm going to add my sneaky 1 in there on the 2 to make sure I remember that it has a positive exponent. And I'm only going to move things to the opposite side of the fraction that contain negative exponents. So what I want you to notice here that is kind of tricky is that this 2 stays put. It has a positive exponent of positive 1. So this is going to become 2 in the bottom because that stays in the bottom. The y to the power of negative 2 moves down and becomes a positive exponent. And then the exponent for x becomes positive as it moves up. And same thing for z. And then if I look, I've taken care of that step there. Then it says combine common bases across top and bottom. That doesn't apply. And the division property also does not apply here.